We are in our next unit, which is all about systems of equations. So let's start with the first problem. It says determine whether each ordered pair is a solution to the system. So to be a solution, you have to be able to plug in an x and a y into both equations, and it will be a true mathematical statement. So we'll start with A. And we'll plug it into the first equation. So 2x, so x is -1, plus y, and it should equal 5. So when we sub that in, it does not equal 5. So that means A is not the solution. So then we do B. 2 times the x, so 2 times 3, plus the y. I guess I should have put what y is. -5 equals 5. So that'd be 6 minus 5. That does not equal 5. That equals 1. So B is not it either. Okay, C, 2 times 4 plus 4, because that's x and y, equals 5. So that'd be 8 plus 5, 4. So 8 plus 4 is 12, which does not equal 5. So again, no. Okay, D. So the equation is 2x plus y. That'd be 4 plus 1 is 5. So the first one worked. So now we got to use the second equation. So 3x, so 3 times the x, 2, plus, or minus, actually, minus 2 times y equals 4. So that'd be 6 minus 2 is 4. 4 equals 4. So our solution will be 2, 1. So that is how you use substitution whenever you're given some solutions in order to check which one is true. So let's go to solving by substitution and then verifying graphically. So what we would need to do is solve for one variable, substitute into the other equation, solve for the variable, and then solve for the other variable. So we have to solve for both x and y. So I'm going to rewrite this. I'm going to say, since I'm going to have to do this graphically in a little bit, I'm going to go ahead and do this. So y equals -x plus 4. So I'm going to plug in this for y here. So x minus -x plus 4 equals 2. So it's like I have to distribute a -1, so plus x minus 4 equals 2. So 2x minus 4 equals 2. Now solve. So plus 4, we get 2x equals 6. Divide by 2, x equals 3. Okay, so we solved for one of the variables. Now we have to solve for the other variable. So I can actually plug this into that equation. So y equals negative, x is 3 plus 4. So y equals 1. So then our solution is x comma y. So 3, 1 is our solution. So we want to verify using the calculator by graphing. So in order to graph it, we have to have it in the y equals form. So we already have this one. So we need to solve this other one in y equals form. So it would be negative y equals -x plus 2. And then we divide by a -1, so y equals x minus 2. So I'm going to put both of those into the calculator and make sure that they do, in fact, cross at the solution that we came up with, 3, 1. So go to y equals. Let's clear everything out. Clear. Oh, go back. I'm just going to clear second plus 7, 1, 2. All right, now go to y equals. So we have -x plus 4. And then the other one is x minus 2. So put those in, hit graph. And then we would use the calculate feature. So we would do second trace. We want to find the intersection, 5. Left bound is one of the lines, right bound is the other line. Guess, enter. Let's try that again. Let's see. Left bound. Oh, I got to go over to right bound. Right bound. Guess, enter. Okay, so the intersection is right there. It says x is 3, y is 1. I think it looks different on y'all's calculator. So it is 3, 1. Okay, so let's go back. Let's go to number 2. We are going to follow the same steps. Solve one of them for a variable, plug in, solve for the other. I think it'd be easy to solve for y here. So I move over the 2x, that's negative 2x plus 5. So I'm going to plug this in for the x, right, or for the y right here. So it's 3x minus 2 times negative 2x plus 5 equals 4. So we need to solve for x. So 3x plus 4x minus 10 equals 4. 7x minus 10 equals 4. Add 10 to both sides, so we get 14. Divide by 7 on both sides, x equals 2. So we have one of the values. Now we need to plug that in. So I'd say it'd be easy to plug it back in here. So y equals negative 2 times 2 plus 5. So y equals 1. So our solution is x comma y, 2 comma 1. We want to verify with the calculator again. So we are going to, we already have this one solved. We need to solve this one right here. So negative 2y equals negative 3x plus 4. All I did was move over the 3x, divide by negative 2. So y equals positive 3 over 2x minus 2. Plug these in the calculator to see where they intersect. Double check that they intersect here. Okay, let's go to number 3. I'm going to save time and let y'all do that checking with your calculator on your own. So let's go to the next one. I'm going to solve this one for a variable. If I move over the y, I get x equals y, or y equals x. So x and y are going to be the exact same. So all I have to do is replace this with an x, or replace this with a y. It's up to you. So let's do 5x minus 3x equals 6. 2x equals 6. Divide by 2, divide by 2, x equals 3. And because of this, y equals 3. So our solution is 3 comma 3. Okay, we are going to save number 4 for in class. And see what else. What do we need to go to next? We're going to also save 5 for in class. And let's go to number 6. So notice that we have a linear here, and then we have a cubic here. So a linear and a cubic could cross up to 3 times. Think about it. If I have a linear and then a cubic, it could look like that. And look how many times they intersect, up to 3 times. But it doesn't have to be 3 times, but it can be. So we're going to see how many times it crosses. I'm going to move this 3x over to the other side to find out what my linear is. And then I'm going to plug this in for the y right here. X cubed minus 2 minus 3x plus 2 equals 0. X cubed minus 3x. And then we have negative 2, positive 2, which cancels to get 0. So it's just x cubed minus 3x. So factor out the x. And then solve. So we have x equals 0. And we have x squared minus 3 equals 0. So then we would have 3, take the square root. So x equals plus minus square root of 3. So we actually have 3 solutions. We have where x is 0. I'm going to say x is square root of 3 positive, and x is negative square root of 3. Okay, the reason I separated them out like that because I need to find the y that matches. So I'm going to substitute this into this equation. So y equals negative 3 times 0 plus 2. So y equals 2. So one of my solutions is 0, 2. Okay, I'm going to go up to the positive square root of 3. So y equals negative 3 times the square root of 3 plus 2. I can't combine anything there, so that is my solution right there. So x is square root of 3, y is negative 3 square root of 3 plus 2. So they're irrational, but that's okay. And then the next one is y equals negative 3 times negative square root of 3 plus 2. So y equals, that'd be positive 3 square root of 3 plus 2. So our solution would be negative square root of 3, and the y value is 3 squared roots of 3 plus 2. Okay, so we actually have 3 solutions. Here, here, and here. Okay. And we're going to save 7 and 8 for in class also. And then we have 1 and 2 down there. Actually, instead of this being in class, I want you to do this one and answer it on your own.